All right, in this video we're going to talk about how to find the arc length of certain curves. And this is a pretty basic video here. To find the arc length of a curve, all you simply do is integrate from A to B, and we're going to use the letter S to represent the arc length. So S is equal to the integral from A to B of the square root of 1 plus f prime of x squared dx from A to B. And this is actually a good opportunity for us to review some chain rule and derivative rules that maybe we've forgotten over the past month or two. So example 1, let's just jump right in. Find the arc length of the curve y equals 1/3 x squared plus 2 to the 3/2 power on the interval from 0 to 1. All right, so our f of x is 1/3 x squared plus 2 to the 3/2 power. Our f prime of x is going to require us to use the chain rule. So we're going to do 3/2 times 1/3, which is going to give us 1/2. Leave the inside alone. Drop the power down, subtract 1 from 3/2, you get 1/2. And then we got to remember chain rule, got to multiply by the derivative of x squared plus 2, which is 2x. All right. And we see here that the 2's are going to cancel. And that's simply going to leave us with the function f prime of x equals x times, well, tell you what, why don't we write it as the square root of x squared plus 2. All right, so now we're going to throw this into our formula for arc length. And so our arc length is going to be S equals the integral from 0 to 1 of the, actually, you know what? Before we do that, let's just get f prime of x quantity squared. Let's do that because that's what we're going to actually plug in. So if I square this guy, if you square the x, you get x squared. If you square the square root, you simply get what's underneath the square root, which is x squared plus 2. And if you distribute that, you get x to the 4th plus 2x squared. All right, so we're going to plug that into our formula, and we get the square root of 1 plus the stuff that we just got, f prime of x squared. So that's going to be x to the 4th plus 2x squared dx. All right, and we can recognize that this is simply something that we can factor, and that's going to factor into square root. It's going to factor into x squared plus 1 and x squared plus 1. So x squared plus 1, x squared plus 1. And if you're not sure, you can kind of work that out on your own. And that's going to end up giving us the square root of x squared plus 1 quantity squared. Well, the square root of something squared is just the thing being squared. So that's going to end up giving us simply the integral from 0 to 1 of x squared plus 1 dx. And we're going to continue this up here. So we are going to integrate that, and you get x cubed over 3 plus x. And we're going to integrate that from 0 to 1. Plug in your 1, you get 1/3 plus 1. Plug in your 0, you simply get 0. So the answer is going to be 4/3. Ooh, that's an ugly 4. Let me try that again. Answer is going to be 4/3. That's a little better. All right, on to the next question. All right, second to last example with arc length is going to be a calculator required problem. And so let's see if we can set this up here. we are given the function in terms of y. So f of y is equaling y squared over 4 plus 1 over 2y. And we're going from y equals 1 to y equals 3. So the first thing we want to do is we want to take the derivative of this. So f prime of y is going to equal, looks like 1/2 y. And if we bring the y up, don't bring the 2 up, but if we bring the y up, that's going to give us a y to the negative 1. So we're going to multiply that in front. All right, and that's going to take us to y to the negative 2. And so our integral is going, excuse me, our derivative is going to be 1/2 y minus 1 over 2y squared. All right, and then we want to tell you what, why don't we write this as y over 2 minus 1 over 2y squared. And we will get a common denominator by multiplying top and bottom by y squared. So let's put that in there, times y squared times y squared. And that's going to give us y cubed minus 1 over 2y squared. And that is f prime of y. So if we square that, so f prime of y quantity squared is simply going to be this whole thing. So let's just put it like this, y cubed minus 1 and over 2y squared, all squared. All right, so now we're going to take this and plug it into our formula. So the formula for arc length is s is equal to the integral. In this case, it's from 1 to 3 of the square root of 1 plus this thing. So it's going to be y cubed minus 1 over 2y squared, all squared, dy. And plug that into your calculator and you will get approximately 2.68 as the arc length. And that is the answer to this problem.